Ignore, 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 ignore. Number 1. Using the data in the table, Jamila observed that September had the greatest number of hurricanes. We are talking about hurricanes by month. What can Jamila infer from this data? So what can she make a guess about? When we talk about months, okay, think about the things we can make inferences about, especially when we see the pattern, okay? So it says that June, we have 19. July, we have 25. August, 76. September, 104. October, 51. November, 5. And then the rest of the months of the year, December through May, there are none. So what can we infer? A says hurricanes occur most often when water temperatures are the hottest. Well, can we talk about temperature in months? We definitely can. We know that June, July, August, September, these are hot months in the United States, okay? And that's where I see most of my hurricanes versus January, February, December. These are cold months, and I see that there are no hurricanes. So would it be fair to say that they occur most often when water temperatures are hottest? Yes, that's a good answer. B says they form when the ocean and air differences are the greatest. There is no way for us to know that the ocean and air are different at all because that's not what this graph tells us. This graph only tells us hurricanes by month. C says hurricanes occur in states with coastlines. Again, it does not tell us about different states, so we cannot say what different states that hurricanes occur in. And D says hurricanes form over cool ocean water. Well, if that was true, I would expect there to be a lot of hurricanes in cold months if they form over cold ocean water. So that tells me that D is not true, and A is the correct answer for number 1. Number 2 says wind energy is created by the uneven heating of the Earth's surface by the sun. Which of the following best describes how wind works? So, one thing we need to review about wind before we get into this question is hot air versus low air. Because, again, like it says, wind energy is created by uneven heating. So, how hot air and cold air interact. Hot air is very low pressure, okay? Why? Because hot air moves around super fast, so these air particles are far away from each other. Low pressure. Versus cold air, they move super slow, and they're also very high pressure. Cold moves slowly, so it's going to be high pressure. This is going to affect how different air acts because when air is cold, it sinks because it's heavy. High pressure is heavy. Versus low pressure is light and it's going to rise. Hot air rises. Think about a hot air balloon. Okay, it rises from that hot air. A says when cool air rises, nearby air that's warmer rushes in to fill in the empty space left behind. The rushing air is what we call wind. So this part sounds great. Rushing air is what we call wind, but it is not air moving from hot to cold, okay? Instead, it's going to be moving from a high pressure area to a low pressure area. Remember in class when we said that if there were 20 kids sitting at this table and 2 sitting at this table, all of these kids sitting at the 20 kid table would rush over here because they want to fill in that empty space, and that would be what wind is created by. So when it says warm air rushes in, that's not true. These low pressure kids do not want to rush over there. So that makes this wrong, but also cold air does not rise. So A is incorrect. B says cool air produces low air pressure. Is that true? No. Warm air produces high air pressure. Nope. They have that backwards. Warm air wants to rise. That is true. When warm air rises, cold air will move in and replace the warm air, causing wind. That's true as well. But since the first 2 were wrong, the first half of that question makes B incorrect. C says during the day, the air above the land heats faster than air over the water. This warm air over the land expands and rises. Warm air does rise. And the cooler air, which is heavier, takes its place. Cold air is heavier, and it wants to take the place of that low pressure air over here, causing wind. That is a great answer. This actually illustrates a sea breeze. Sea breeze happens during the day because the land likes to switch up, okay? It heats up fast during the day and it cools down fast at night. So during the day, the land is relatively hot, whereas the water is more relatively cold. So if the land is hot, it's got low pressure air, hot air that's rising. And over the water, there is cold air, relatively cold air, that is heavy and sinking. And so it's going to create this convection current when it moves from high to low pressure. Remember, when it goes from high to low, from high pressure to low pressure is the wind. So C is a good answer. Last one, D says cool equatorial air. I can see the word equator in this word. Do I have cold air at the equator? No. Does cold air like to rise? No. And migrate toward the poles. At the same time, warm, denser air. Is warm air dense? Heavy? No, it's light. Moves over the Earth's surface toward the equator to replace the cooled air, creating wind. That is actually the opposite of what happens. We're going to talk about that in a later question. So C was the correct answer there. Number 3, at night, the land cools off faster than the ocean. That's the opposite of the sea breeze during the day that happened before. So at night, the land, remember it likes to switch up, land always wins, is relatively cold, whereas the water is relatively hot. Oops. So everything from before is flipped. There's hot air over the water. There's cool, dense air over the land that is sinking. This warm air is rising, and wind happens as it rushes from high to low. That's the way it always flows. Wind, it blows from high to low. So, what event is caused by this difference in cooling temperatures? The difference is very important. Difference is always going to point towards winds. So C is the correct answer. All the other ones have to do with rain, which is not caused by a difference in temperature. Number 4, local weather varies across Florida. The temperature at the beach may be up to 5 degrees cooler than the temperatures inland 20 miles away. What is the reason for this difference in temperature? Reason for the difference in temperature is always going to have to do with the difference between water and land. So A says the ocean reflects energy into the atmosphere. B says the land distributes the thermal energy equally. C says the land and water create convection currents. And D says the water and land heat unequally. So it's talking about the temperature at the beach. Okay, let's imagine Florida. So the temperature at the beach right here being cooler than it is inland right here. So it's cooler here. Why? It is not just because the land and water heat unevenly, because we're talking about comparing land and land. Okay? Instead, what's the difference between these two things is that this land at the beach is nearby water. And the land and water together are creating convection currents, which is what we see here and here. So because land and water create convection currents, that is why there is a difference in temperature between the coastline cities and the inland cities. Number 5, Differences in air pressure drive the global wind systems on Earth. Which term describes polar winds that blow from east to west? The word from east to west are the most important here because winds are named by where they came. From. Winds are named by where they came from. So where did these winds come from? They came from the east, so it's going to be named after the east. It's going to be easterlies. Wind is named by where it came from. So this is called a land breeze because it came from the land to the water. This is called a sea breeze because it came from the sea to the land. So wind is named by where it came. Important to know for your test. And number 6, air rising and sinking in Earth's atmosphere forms a pattern of smaller convection cells. These convection cells create both high pressure belts and low pressure belts. Where in the preceding diagram are there low pressure belts located? So pressure, again, has to do with temperature, and we want to know about low pressure. Well, I know that low pressure means that the air particles are going to be far away, so I'm looking for where is it hot. Let's look at this picture of the Earth. I know that it is not hot at the North Pole, and it is not hot at the South Pole. That means that the air is going to be sinking towards the Earth at these places because it's a high pressure area. I'm going to write H for high pressure. H for high pressure. I see the opposite at the equator where there is warm air. Because it's warm, it's going to be rising away from the Earth because it is low pressure. So automatically, if I know that it is low pressure, I probably shouldn't draw it over the answer choices. Low pressure at D, I know it has to be either A or C. I can get rid of B because there's no D, equator. And D has D as well. So we got to keep talking about it. So these convection currents that we talked about before with the sea breeze and the land breeze are a result of warm air rising and cold air taking its place, okay? Well, when warm air rises, eventually it starts to cool down, and so it will begin to sink. That means at 30 degrees north is where that warm air from the equator has cooled off and sank, and the same thing at the 30 degrees southern down here. The same thing happens, okay? We're going to feel winds going from C to D and from E to D because that's going from two high pressure areas to the low pressure area in the middle. Once we have a low pressure area here, it's not just going to want to go down over here, but it will also go over here. It'll eventually heat up and rise again. So we're going to find a pattern. The high pressure air at E splits off either way. Eventually it rises again at F. Okay? When it rises, it's going to eventually cool down and sink in either direction. Sink in either direction. And that creates these convection currents that we can see here. So the convection currents are what distribute the air, but let's talk about where the low pressure area is at. The low pressure area is where I see them rising. So there is a low pressure area at the 60 degrees north, which is B, one at the equator, D, and low pressure at 60 degrees south, which is F. So the correct answer here is